So, you want to know why you might need one of these? Well, the short answer is because this exists, and because this isn't this. But for the long answer, you're going to have to keep watching. This is my network storage server. It's got a bit over 50 terabytes of storage, packed into Fractal Design's Define R6 case. The biggest limitation of this server is its network connection. I'm using the motherboard's built-in Ethernet port. Now, gigabit speeds aren't bad, but good luck impressing the ladies with your 1 gigabit connection. For that, we're going to need one of these. These are 10 gigabit network cards that each have 2 SFP Plus ports, and each port is capable of 10 times the speed of a typical gigabit Ethernet port. 10 gigabit networking has been the standard for servers and enterprise equipment for almost 20 years, but it hasn't seen much adoption by home users, mostly due to the high cost. In the last few years, second-hand server cards like these have become relatively affordable. Switch manufacturers are also getting in on the action, and you can often find switches with a couple of 10 gigabit ports for under $50, like this one from Nick Giga, although you might want to skip this brand if you're dyslexic. While second-hand server hardware like this is cheap and extremely reliable, it does have a few downsides. Most notably, its high airflow requirements. These cards have a minimum airflow requirement of 100 feet per minute, which is nothing for a server, but it can be difficult to achieve in a standard PC enclosure. Some network cards have built-in fans, but most rely on the server for cooling. Which brings me to this. This is the sort of fan you might find in your home computer. And this is the server fan she tells you not to worry about. At first glance, they might not look all that different, but that's until you notice the power consumption. The regular fan sips power, barely using over 1 watt, while the server fan draws almost 40 watts. The server I pulled it from had 6 of them, meaning the fans alone could use more power than your entire computer. So why don't we just throw in a couple of server fans? Problem solved, right? Well, for starters, most server fans don't use a standard connector, so you can't just plug them into your motherboard. And even if you could, most motherboard fan headers can only supply 1 amp, less than a third of what one of these fans needs. In case you still need a reason to avoid them, let me demonstrate. But first, I'm going to need a pair of these. So unless you want to blow out your eardrums or your motherboard's fan controller, we're going to need another solution. But before we go into that, let's install the network card and see how it performs without any extra cooling. You want to check your motherboard's manual to decide which slot to use for the network card. This can depend on what CPU you have and what NVMe or SATA ports you're using. In my case, placing it in the 4th slot right below the GPU should give me the best bandwidth. Metallic surfaces behave like a mirror to a thermal camera, so I'm going to apply a small bit of black electrical tape to the card's heatsink to make sure I can get an accurate temperature measurement. I want to test a best case scenario, so I've removed the transceivers, left the side panel off, and I'm going to let the machine idle at an ambient temperature of 22 degrees Celsius. While I wait for temperatures to stabilise, I'll measure airflow inside the system. The only air reaching the card is from the front intake fans. The speed isn't high enough to measure with my equipment, but I'd estimate it's less than 1/10 of what the card requires. Even the highest airspeed in the system, between the CPU heatsink and rear exhaust fan, barely reaches 100 feet per minute. After idling for 10 minutes, the edge of the heatsink is already at 65 degrees Celsius. The back of the card is the hottest point in the entire system at over 70 degrees, or around 50 above ambient. I couldn't get an accurate temperature reading on the controller, but it wouldn't surprise me if it was 10 degrees warmer than the back of the card. Now, this might be okay if you live in the Arctic and keep your computer outdoors, but if this thing is going to survive the Australian summer, I'm going to need to add a fan. Now, full disclosure, this is a product I design and sell, though it's completely open source if you want to build one yourself. I'm also going to show a budget-friendly option later in the video. To give myself some extra room, I've decided to use one of Acasa's slim 80mm fans, but any 80mm fan with a 4-pin connector should do the trick. I provide rubber fan mounts to reduce vibration. They don't require any tools to install and are compatible with most fans, but you can use screws instead if you prefer. Once I've attached the fan, I can trim off the excess rubber. With the fan mounted, I can use one of the included cable ties to clean up the excess fan cable, then plug the fan into its connector. I'm going to place the fan in the bottom PCIe slot to give myself some extra room to measure airflow and temperature. If I wanted to use a thicker fan, I could install it right below the network card. I'll set the fan speed to 75% for testing, although I can probably reduce this later. The airflow at the heatsink clocks in at around 400 feet per minute, 4 times higher than the network card requires. Even at the fan's lowest speed, I still get around 200 feet per minute, which should be more than enough to keep it cool. After the system has warmed up, the heatsink is still barely over 30 degrees Celsius. The back of the card, which was previously the hottest point in the entire system, is now only 34 degrees, with the voltage regulators being the warmest point on the card at 37 degrees. This gives me plenty of room to reduce the fan speed, while still keeping the network card cool. I'll go with 50%, but I could easily lower it to 25% if noise was a problem. I keep it in a separate room, so I don't mind trading a bit more noise for lower temperatures. If you're looking for a cheaper alternative, PCI fan brackets are available for around $10. These are simply brackets for mounting a fan, and don't include a fan controller or power supply, so you'll need a spare fan header on your motherboard. The bracket I bought has mounting points for 80, 90 and 120mm fans. It also includes couplers for mounting multiple fans, although I wouldn't recommend using more than one without extra support. The bracket is wider and thicker than a standard PCI bracket, so you want to make sure that it can fit in your case. I mounted a 120mm fan with the included screws, then attached it to an unused fan header on the motherboard. I ended up having to remove the neighbouring PCI slot cover to fit it in. You'll want to disable automatic fan control and set the fan to a constant speed, as the motherboard can't monitor the network card's temperature and could allow it to overheat. Thanks for watching. I've put links to both options in the description below.